So hello everyone. Um this is the lesson 2 of design analysis and algorithms, and we are going to talk about problem types and fundamental data structures. So in this lesson we will be talking about different problem types so that you will know how can you solve a certain problem. So we have different problem types. So we have the sorting problem type, the search, the graph algorithms, the combinatorial problems, geometric problems, and numerical problems. So the first one, sorting problems. So sorting problems, this kind of problems is a need of rearrangement of items of a given list or a given array in non-decreasing order. So it's either decreasing or in increasing order. So you have to sort certain uh, items or an array of items. So in sorting, we have a different solution in sorting. So we have the bubble sort, we have the selection sort, insertion sort, we have also the topological sort, we have also the merge sort. So throughout this lesson, we are going to tackle about those, and we are going to know how to implement those in programming. So those are types of sorting solutions pertaining to sorting problems. So as you can see in the screen, um, a sorting problem in a sorting solution, so inarrange niya yung group of letters according doon sa arrangement ng alphabet. So, ayan. So, this type of sorting is what we call, sometimes sorting can be through bubble sorting, selection sorting, and insertion sorting. Next, we have the search. So, search is designed to check for an element or retrieve an element from any data structure where it is stored. So, going back from data structure, no, um, if we are pertaining to an array, no, we are going to find kung saan nakalocate yung data. So, kumbaga, sa isang array, titingnan natin kung anong index number ang kinalalagyan ng isang data. So, that is a searching problem. So, we have types of search problems. We have, first one is the sequential search. So, sequential search is the list of array that is traversed. So, pag sinabi natin traverse, pwedeng in increment and or decrement sequentially, and every element is checked. So, every element na i-run or every element na dadaanan is i-check muna kung tama ba yung hinahanap na item or hinahanap na laman. For example, dito sa example na to, which is the linear search, for example, find 20. So, dadaan muna siya kay index 0. So, is index 0, ang laman ba niya is 20? So, kung mali yung laman niya, for example, the index 0 is 10, and then hinahanap natin is 20, magfa-false siya. So, hanggang makita natin yung equivalent number ni 20, doon pa lang siya mag-stop. So, that is sequential search. So, in this example, the 20th item or yung item 20, nakalocate siya sa index na 6. So, that is a linear search or sequential search. Next, we have the interval search. So, interval search, these algorithms are specifically designed for searching in sorted data structures. So, unlike a linear search or sequential search, pwede natin hanapin yung mga items kahit hindi siya nakasort. So, kay interval search, the list should be sorted first before searching. So this type of searching algorithms are much more efficient than linear search as they repeatedly target the center of the search structure and divide the search space in half. So this is the example of a interval search. So one example of interval search is the binary search. So first one, hahatiin muna sa dalawa and then to make sure that every item is sorted. Ibig sabihin, kailangan in order yung mga items na nakapaloob sa isang memory allocation. So, for example, unsorted yan, hindi natin ma-apply sa interval search. So, ma-apply natin sa search for the unsorted items is the linear search. So, for this example of binary search, nakasort na yung mga items natin, no? Hatiin muna in half. And then, for example, ang i-input natin is L is equals to 0, no? Hahanapin muna natin or i-check niya if that particular index is tama yung hinahanap natin. So, that is a search problem. Okay? Next, we have the graph problem. So, graph problem, so this is a nonlinear data structure or nonlinear algorithm problem consisting of nodes and edges. The nodes are sometimes also referred to as vertices and the edge are lines or arcs that connect any two nodes in the graph. So, this is an example of graph problem. So, graph problems are applicable to those problems. For example, we are going to know which path is the shortest path. So, doon natin i-apply yung graph problem. And another one, if we are going to find kung alin sa mga lugar ang mas maraming population. So, yun yung ginagamit natin. Doon natin i-apply yung mga graphic solutions such as TSP or the travel salesman. So, the travel salesman problem is an example of graphic problem wherein we find the shortest path. So, along the way, sa lesson 3, pag-aaralan natin on how can we or what are the solutions, no, to calculate in finding or solving graphic problems. Next, we have the combinatorial problems. So, combinatorial problems, these are problems that ask explicitly or implicitly to find combinatorial subject or object such as a permutation, a combination, or a subset that satisfies certain constraints. So, combinatorial problems, these are the problems that is a mixture of specific solutions. So, kumbaga, combinatorial problems, these are the problems that, kumbaga, yung solution niya, kailangan mo i-include lahat ng mga possible solutions in order to solve that problem. So, that is a combinatorial problems. So, example of combinatorial problems, as a solution for that, you have to use exhaustive search, sometimes a mixture of topological sorting and linear searching, ganon. So, that is combinatorial problems. Next, geometric problems. So, geometric problems, ito yung ginagamitan natin ng mga solution. For example, gagamit tayo ng Euclid's formula wherein we calculate the distance between the following coordinates. So, it deals with geometric objects such as points, lines, and polygons. Okay? So, yun. So, those are geometric problems. Next, numerical problems. It includes mathematical equations, mathematical solutions in order to solve a certain numerical problems. Ayan. So, next, we have to tackle about fundamental data structures. So, fundamental data structures, so, Dahil gumagamit tayo ng data structure, so what is a data structure again as a review? So data structure can be defined as a particular scheme of organizing related data items. So in order for us to apply the algorithm, no, the algorithm para mas maging efficient yung algorithm na ginagamit natin, is kailangan i-consider natin yung paggamit ng data structure para mas maging organized yung pag-implement. Kumbaga, kung paano natin isusulat sa programming yung algorithm natin. So, we have types of data structure. So first, we have the linear data structure. So pag sinabi natin linear data structure, these are the elementary data structures or data structures that are necessary or common na ginagamit. So the first one is array. So array is a sequence of n items of the same data type that are stored contiguously in computer memory and made accessible by specifying a value of the array's index. And linked list is a sequence of 0 or more elements called nodes, each containing two kinds of information. Some data, one or more links called pointers to other nodes of the linked list. So, ang pinagkaiba lang ng array and linked list, though they are both the same collection of items, array doesn't need a connection that links between two or more items or two or more data. While the linked list, kailangan in a sequence yan. In a sequence, in a sense na kailangan lahat ng data magkakaroon ng connection. That connection is what we call a pointer. Kumbaga, copy siya ng certain data para mag-connect doon sa previous data and the next data, or the previous node and the next node. So those are the linear data structures. Next, we have two types of special list or special types of list. So we have the stack and the queue. So gagamitin natin siya especially kapag topological sorting and insertion sorting. So si stack, no? Si stack, ang tatandaan lang natin kay stack, kada pasok niya is nasa huli. So this is the acronym of LIFO, for that is for last in and first out. While sa queue, FIFO, first in, first out, kumbaga sa linya, kung sino yung unang lalabas, sino yung unang pumasok, siya yung unang lalabas. Next, we have trees. So, trees, similar to linked list, kailangan nakakonect yung mga data, kaso yung difference niya, si linked list, nakakonect lang siya sa iisang node. While sa tree, pwede siyang mag-connect sa different nodes or two or more nodes. So, yun lang yung pinagkaiba ni trees at saka ni linked list. So, we have properties of a tree. So, we have the rooted trees, we have the ordered trees. So, rooted trees, every two vertices in a tree, there are always exist exactly one simple path from of these vertices to other. So, ibig sabihin, ibig sabihin, itong example natin dito sa figure 1.11, okay? So, this is a free tree. So, ito yung sinasabi natin na simple tree. Kumbaga, isang node, pero pwede siyang mag-connect sa two or more nodes. So, once na inorganize natin or nilink natin siya, so, one vertex or one vertices or two or more vertices, one vertex dito, ito yung pinaka-root niya. And then, pwede siyang mag-connect dito sa subordinates niya, dito sa baba. And then, kada subordinates niya, meron siyang sariling path. Meron siyang sariling single path. Yan yung rooted tree. And then the ordered tree, it is a rooted tree in which all the children of each vertex are ordered. It is convenient to assume that in a tree's diagram, all the children are ordered from left to right. So, kumbaga, si ordered trees, nakasort yung mga data from left to right. So, I will show you how to sort a unsorted list of items using sorting and also using tree data structure kung paano siya gagawin.